Okay, welcome to part 3, an additional example of how to use the quadratic formula when trying to factor polynomials or quadratic equations. So remember the standard form, the number in front of the x squared is our a value, plus the number in front of the x value is our b value, and our constant left all alone is our c value. So in this example, I'm going to use x squared plus negative x minus 12 equals 0. Now, I wanted to show you how, even though there's no numbers shown or visible in front of these x values, there's really an invisible 1. That's 1x squared plus a negative 1x minus 12. So our a value in using the formula will be the invisible 1. The b value in using the formula will be the negative invisible 1. That negative goes with that term 1. And of course our constant is going to be 12. So we're going to use the formula x equals a negative b plus or minus, right? It's both. You have to include both. Plus or minus the square root of b squared minus 4ac divided by 2a. So everywhere you see an a, you're going to substitute a 1 value, right? Everywhere you see a b, you're going to substitute a negative 1 value. Remember that negative, a lot of people see that as subtraction, but that negative goes with the 1. And then, of course, c equals negative 12. So where we see c, we'll substitute the value of negative 12. Hey, so let's just do that now. Let's substitute these values. And this is what it should look like. So we substituted our b value, negative 1. We substituted our a value, that's the 1. And we substituted our c value of negative 12. Okay, so it is plus or minus. So I wanted to show you how negative 1 squared is negative 1 times negative 1, which is a positive 1. So I've substituted that first term here. Negative times a negative is also a positive, which I will simplify a little bit further. But remember, we take this one step at a time. One step at a time. Let's go ahead and take a look at our next step. And you can see here, I'm showing that positive 1 here. Negative 4 times a positive 1 is negative 4. And negative 4 times a positive 12 times a negative 12 is a positive 48. So I'm showing that step here. Next, positive 1 plus 48 is a square root of 49. Okay, and negative times a negative is a positive 1. Okay, so I'm just simplifying. Now, let's simplify this square root. 49 is a perfect square. I know 49 is 7 times 7, right? 7 times 7. And I'm showing you here, I'm simplifying perfect squares. I got two perfect pairs. I can pull one outside the radical at 7 times the invisible 1. There's an invisible 1 in front of that radical. So 7 times the invisible 1 is 7, which gives us the next step we have down here. So we can get rid of this radical. Now it's positive 1 plus or minus the square root of 49 is 7, all divided by 2. And of course, up earlier, 2 times 1 is 2. I'm showing you that here. So we're going to take 1 and we're going to go positive 1 plus 7 divided by 2 and positive 1 minus 7 divided by 2. That's how you're going to simplify these last few steps. That's what this plus and minus means. It means 1 plus 7 divided by 2 and 1 minus 7 divided by 2. All right, let's go ahead and finish this problem. We have, in our next step, like I said, it's going to be 1 plus 7 divided by 2 and 1 minus 7 divided by 2, which is what you see here in this next step. 1 plus 7 divided by 2 or 1 minus 7 divided by 2. So 1 plus 7 is 8 divided by 2. 8 divided by 2 is 4. Okay, and then you have positive 1 minus 7 divided by 2. 1 minus 7 is a negative 6, right? We have 1 positive, 7 negatives. You add 1 positive, you still have those 6 negatives. Divide by 2 gives us a negative 3. So our factor for that original equation is 4, negative 3. Now let's check our answers. We have x equals 4 and x equals negative 3. So one at a time, we're going to substitute 4 and negative 3 into the original equation. Okay, so as you can see, if you would have factored normally, you would have factored to find two numbers that multiply to a negative 12 and add up to that negative 1. And both positive 3 times a negative 4 would multiply to negative 12, right? And if you add a positive 3 plus a negative 4, that would give you the negative 1 here. So normal traditional factoring, you would have chosen positive 3 and negative 4 to use the reverse FOIL, right? So that's what we're doing here. I'm showing you the reverse FOIL. So x plus 3 equals 0 and x minus 4 equals 0. That's what I'm showing you here, the two different equations. We subtract 3 to both sides to get rid of that 3, and x equals negative 3. Or we add 4 to both sides. That cancels the 4. Leaves me x equals positive 4. So we've checked our answers. You can also, in checking your answers, substitute 4 for x. 4 times 4 is 16. 16 minus 4 is 12. 12 minus 12 is 0. And if 0 equals 0, then yes, x has got to equal 4. Same thing with negative 3. You could substitute negative 3 in the original equation. Negative 3 squared is positive 9. Minus 3 is a 6. I'm sorry, negative and a negative make a positive, so that would be a positive 3. So 9 plus 3 is 12. 12 minus 12 is 0 equals 0 is a true statement. X has got to equal 4, and x has got to equal negative 3. So this was part 3, quadratic equation, second example. I hope you found this helpful.